Okay guys, I welcome you all to Engineers Academy. Do subscribe my channel if you haven't done it yet. Now we are going to solve this problem from chapter 12, Hibbeler Dynamics. The problem says that at the instant shown, the car at A is traveling at 10 meter per second around the corner while increasing its speeds at 5 meter per second square. So this car A is moving with a velocity of 10 meter per second and an acceleration of 5 meter per second square. The car at B is traveling at 18.5 meter per second along the straightaway and increasing its speed at 2 meter per second square. Determine the relative velocity and relative acceleration of A with respect to B at this instant. So we have to find the velocity of A with respect to B, which is equal to VA minus VB. And similarly, we want to find the relative acceleration of A with respect to B, and which will be equal to the acceleration of A minus the acceleration of B. Now we can solve this problem by using two methods. One is the graphical analysis and the other one is the vector analysis. So I will solve this by using those two methods, right? So we will find VAB by using the graphical analysis. So the graphical analysis is by head to tail rule we can find VA minus VB. So now as we can see that VA is in the tangential direction. This VA is tangent to this curve, right? So if we draw a line, this is the radial line, so the velocity is tangent like this. And if I extend this radial line, and here if I draw a horizontal line, so as we can see that this angle is 45 degrees and this angle is 90. So as we can see that this angle is also 45 degrees. So this VA, which is tangent to the path, is making 45 degrees with the horizontal. Since if this is the normal axis, then this VA is also making 90 degree here as well. So if this is 90 and this is 45 degrees, then this angle is 45 degrees. So this is confirmed that VA is making 45 degree with the horizontal in the clockwise direction. So now by vector addition we can say that VAB vector, this will be equal to VA vector minus VB vector. Now VA vector is, let me draw VA vector. VA vector is making 45 degrees with the horizontal. So let's say this is our VA vector, let's see, and it is making that 45 degree here. And similarly VB, so VB is acting from left to right. So if we want to subtract this VB from VA, since this is VA minus VB, so we have to reverse the direction of VB. So VB is acting from left to right. So to find VA with respect to B, the velocity of A with respect to B, we have to reverse the direction of VB. So the reverse direction of VB is going to act in this direction. So this is the reverse direction of VB. So this is VA. Its magnitude is 10 meter per second. This is VB, but it is in the opposite direction, so its magnitude is 18.5. This is 18.5 meter per second. So from the tail of the first to the head of the last, this will be the relative velocity of A with respect to B. This is the relative velocity of A with respect to B. So now if this angle is 45, then VA is also making 45 degree angle here, since both of these angles are alternate angles. So we can say that this angle is also 45 degrees. Now we can find the magnitude of the velocity of A with respect to B by using the law of cosines. So by using the law of cosines, we can say that VAB square will be equal to VA square plus VB square minus 2VA VB cos of the included angle, which is 45 degrees. Now we can write that VAB if we want to find VAB magnitude, then we have to take the square root. So then this will give us the velocity of A, the relative velocity of A with respect to B magnitude. This will give us the magnitude. Now we can write that VA is 10, so this is 10 square, VB is 18.5 square minus 2, VA is 10, VB is 18.5 cos of 45 under the square root. So this will give us the magnitude of the relative velocity of A with respect to B. So this is 10 square is 100 plus 18.5 square minus 2 into 10 is 20 into 18.5 cos of 45. So this gives us the magnitude of the velocity of A with respect to B equals to 13.44 meter per second approximately. So this is that velocity of A with respect to B. So this is the graphical method, right? By using the head to tail rule, by subtracting the vector of B from vector of A. So this will give us the VAB magnitude. Now the other method is that we can find the Cartesian vector of VA and VB and then we add them, right? So if we find if we resolve this VA into its components, let's say that VA is making 45 degree with the horizontal. So if we resolve it, so it will have one component in this direction and it will have one component in the downward direction. And if this is our positive X and Y direction, so then this is VAX and then this component is VAY. So now we can write that VA vector is equal to, so VAX is, this is VA is 10 meter per second, so this will be 10 cos of 45 and then this will be 10 sine of 45 degrees. So now we can write that this is 10 cos of 45 and this cos component, this is acting in the positive X, so this is in the positive I, and the sine component, this sine component is acting in the negative Y, so this is minus 10 sine of 45 J, and this will give us 7.07 I minus 7.07 J. And similarly this VB is acting along the positive x-axis and its J component is 0, so we can represent this VB in terms of its Cartesian vector. So VB is equal to 18.5 in the positive I, and the units of this is in meter per second, and similarly this is also in meter per second. Now to find that magnitude, the velocity of A relative to B, so we have to subtract VB from VA. So this is VA minus VB. Now we have VA is 7.07 I minus 7.07 J minus VB, which is 18.5 I. So the velocity, the vector of velocity of A with respect to B, this is equal to, so this is 7.07, so we have to subtract I from I, so 7.07 minus 18.5, so this gives us minus 11.43, so minus 11.43 I and minus 7.07 J. So now this gives us that the vector, the relative velocity of A with respect to B vector has an x component of 11.43 and minus 7.07. So we can see from that graphical analysis that the x component of VAB is acting towards the negative x-axis. If we resolve this VAB into its components, so it will have one component in this direction and it will have one component in the downward direction. So we can write that this is that minus 11.43 meter per second and this is that minus 7.07. So this is acting in the negative x, this is acting in the negative y. Now since we have determined this 13.44 meter per second, so we can find that same magnitude by finding the magnitude of this vector. So by finding the magnitude of this vector, we can say that the magnitude of the relative velocity of A with respect to B will be equal to minus 11.43 square by using the Pythagoras theorem. So this will be equal to plus minus 7.07 square under the square root. So this gives us minus 11.43 squared plus minus 7.07 squared. So this gives us that same answer, which is approximately 13.44. So this is 13.44 meter per second. Now we can find this vector, this same vector, from that graphical analysis as well, right? So now how we can find these components, that the x components of VAB is 11.43 meter per second and the y component is 7.07 meter per second in the negative y direction. So how we can do it? We can do it by finding the angle of VAB with respect to the x-axis. So if we find this angle, let's say that this angle is theta, so then we will be able to resolve this VAB into its components. So if this angle is theta, so this angle is also theta, since this angle and this angle, both of these angles are alternate angles. So again, by using the sines law, we can find this theta. So how we can find this? By using sines law. Let me put this on one side. Now if we apply sine of theta, if we apply sines law, so we will have sine of theta divided by the length of the opposite side. So the length of the opposite side is 10. So sine of theta divided by 10 will be equal to sine of 45. This sine of 45 and the magnitude of the length of the opposite side, which is VAB, and that VAB has a magnitude of 13.44. This is 13.44. So now if we cross multiply both sides with 10, so we will have its sine of theta equals to this thing, and we can write that theta is equal to sine inverse, that is 10 sine of 45 divided by 13.44. So now we can find this. This is sine inverse. This is 10 sine of 45 divided by 13.44. So this gives us theta equals to 31.744 degrees. So now this VAB vector is making 31.744 degree angle with the horizontal. So now we can resolve this VAB into its components. So it will have two components. One of its components is going to act in the negative x, and one of its components is going to act in the negative y, like this. So now if this angle is theta and this is VAB, then this is, and VAB is 13.44, then this component is 13.44 cos of that theta, which is 31.744. So now if we determine this, this will give us 13.44 cos of 31.744, which gives us 11.43 approximately, that we have obtained from that vector addition. So this is equal to 11.443 meter per second, and it is acting in the negative x direction. If this is our positive x and y direction, so this component is acting in the negative x direction. Similarly, we can find this component. This component will be 13.44 sine of that theta, which is 31.744. So this gives us 7.07. So this component is 7.07. It is acting in the negative y. So we have obtained that same vector here. This is minus 11.43 in the negative I and 7.07 in the negative j. So now in this problem, we are also required to determine the relative acceleration of A with respect to B. So now if we look into these two cars again, so this uh, this car B has an acceleration of 2 meter per second square. It is said that the car at B is traveling at 18.5 meter per second along the straightaway and increasing its speeds at 2 meter per second square. So now the acceleration of this car B is acting towards the positive x, and it is, let's say that this is acceleration of B and this is 2 meter per second square. Now the acceleration of A is increasing at 5 meter per second square, and this acceleration is tangent to the path. If this is tangent to the curve. So now if I represent it, let me write that let me copy this figure first. So this is, so now we can show that the acceleration of this car A is going to act tangent to the curve, just like the velocity. So this is the acceleration of A in the tangential direction, and since this car is moving in the circular path, so it will have the normal acceleration, and that normal acceleration will be acting towards the center of the circle. So this is the normal acceleration of A. So we can write that this is A in the normal direction. So now the tangential acceleration, this is given as here, this is given as this is 5 meter per second square. This is 5 meter per second square. And similarly, if that velocity VA is making 45 degrees with the horizontal, as we have determined this, so that same the tangential acceleration is also making that same theta angle here, which is 45 degrees. So now we can find the acceleration of A in the normal direction, as we know that AN, this will be equal to VA square divided by radius of curvature, and VA is 10. So this is 10 square, and the radius is 100. So 10 square is 100 divided by 100. This gives us 1 meter per second square. Now the car A has the tangential acceleration and the normal acceleration. Now we have to find the Cartesian vector representation of the acceleration of A. So then we have to resolve this tangential acceleration into its components along the x and y axes. So if we resolve this tangential acceleration into its components, so it will have one component which is going to act in this direction, and it will have one component which is going to act in the downward direction, and this angle is 45 degrees. So now this component is the AA tangential in the x, and this is AA tangential in the y direction. So now we can write that AA tangential, so this is AA tangential x, and this is, as we can see, if this is our positive x and y, so this component is acting in the negative y direction, so we will write that this is minus AA tangential in the y direction. So now we can see that AA tangential, this will give us the vector, right? So this is, now the AA tangential x is the cos component, so we can write this is 5 cos of 45, and similarly the other one is minus 5 sine of 45 degrees. And we can write that this is in the positive I and this is in the negative j. So this is the Cartesian vector representation of that tangential acceleration of that car A. Similarly, as we can see that this AA is making 45 degrees. We have shown that this is that AA towards the center. So then again it will have two components since it is making 45 degrees. So now we can resolve this. Let me write that this AB is, so now if we resolve this normal acceleration of the car A, so it will have two components. It will have one component in this direction and it will have the other component in this direction. And since we know that this is the acceleration of A in the normal direction and its magnitude is 1 meter per second square, and it is making 45 degrees. It is making 45 degrees here. Here it is making 45 degrees. So if it is making 45-degree angle here, it is going to make 45-degree angle here as well. So it will have one component in this direction, and it will have one component in this direction as well. So this one will be 1 cos of 45, and this one will be 1 sine of 45 degrees. So now we can write that AA in the normal direction, this is equal to, so this component is acting in the negative x. So we have to write that this is minus 1 cos of 45 in the negative I, and this component, this 1 sine of 45, is acting in the negative j. So we will write minus 1 sine of 45 in the negative j. Now if you want to find the Cartesian vector representation, we have to add both of these. We want to have the acceleration of A, the Cartesian vector of the acceleration of A along the x and y. So we have to add the tangential acceleration. This is A tangential acceleration vector plus A the normal acceleration vector. So this will be this acceleration will be the acceleration of A along the x and y coordinate system. So now we can write that AA. So now we have to add this and this. So this is 5 cos of 45 minus cos of 45 in the I, and then we have to add this and this. So we have to write plus minus 5 sine of 45 minus sine of 45 in the j. So now 5 cos of 45 minus cos of 45, this gives us 2.828. This is 2.828 in the positive I, and then minus 5 sine of 45 minus sine of 45, this gives us minus 4.242j. So now this is the acceleration of that car A along the x and y. So the acceleration of car A has 2.828 meter per second square component along the x-axis and minus 4.242 in the 4.242 meter per second square in the negative j direction. So this is in meter per second square. Now we have that acceleration of car B. The acceleration of car B is in the positive x, and it has a magnitude of 2 meter per second square. So we can write that AB vector is 2 in the positive I, and its magnitude is in meter per second square. Now the acceleration of the relative acceleration of A with respect to B will be equal to the acceleration of A minus the acceleration of B. Now the acceleration of A is this. So we have to write that this is 2.828I minus 4.242J minus the acceleration of B, which is this. This is 2I. This is 2I. So now we have to subtract I from I component. So this minus this will give us 0.828I minus 4.242J. This is the acceleration of A with respect to B. And if you want to find its magnitude, so the magnitude of the relative acceleration of A with respect to B will be equal to 0.828 square plus 4.242 square under the square root. This is 0.828 square plus 4.242 square. This gives us 4.322. So this is 4.32 meter per second square. So this is the relative acceleration of A with respect to B magnitude. Now if you want to find the direction of the relative acceleration of A with respect to B, so as we can see that this is the Cartesian vector representation of the acceleration of A with respect to B. So from this we can draw the Cartesian vector of A with respect to B, let's say. So as we can see that one of its components is acting in the positive x, so it will have one component in the positive x like this, and it will have one component in the negative y, that is in the negative j. So let's say this is that component, and these are the components of the acceleration of A with respect to B. So this is that, so this is 0.828, this is 4.242, and this is the acceleration of A with respect to B. Now we can find this angle theta. So this is the angle of acceleration of A with respect to B with the positive x-axis. So we can find the theta by applying tan theta. So tan theta will be equal to 4.242 divided by 0.828, and if we take tan inverse, that will give us the theta angle. So now theta is equal to tan inverse 4.242 divided by 0.828. So this is 78.95. So this theta is 78.95 degrees, and this angle is with the positive x-axis, and this is in the clockwise direction like this. Now the velocity of A, the relative velocity of A with respect to B has a magnitude of 13.44, and it is making 31.744 degrees in this direction, right, like this. So let me write the answer, that relative velocity of A with respect to B has a magnitude of 13.44 meter per second, and its angle is 31.744, and it is measured in this direction with the negative x-axis. This is that angle, and similarly the magnitude of the acceleration of A with respect to B is 4.32. Let me write that the acceleration of A with respect to B magnitude is 4.32 meter per second square, and it is making angle 78.95 degrees, but this is with the positive x-axis is like this. So this is that theta. So this is the solution of this particular problem. I hope this will help you in your learning. If it helps in your learning, do subscribe Engineers Academy